Bismillahirrahmanirrahim. With the name of Allah, who is very kind and merciful. Welcome to KingCambridgeSolution.com. On this website, you will find the solution for Cambridge International AS and A level and O level. Today, I shall explain some question of Mathematics 9709, Paper 3, Variant 2, Session 2, Banova 2024. The question number 1 is expand 9 minus 3x whole raised to power 1 by 2 and ascending power of x up to and including the term in x square. Simplify the coefficient. In the solution section for this, 9 minus 3x whole raised to power 1 by 2. After simplification, we get 3 into 1 minus x over 3 whole raised to power 1 by 2. We shall apply binomial expansion formula for this. So, binomial formula is 1 plus x whole raised to power n equal to 1 plus nx plus n into n minus 1 over 2 factorial x up to so on. So, apply the binomial expansion formula on the above expression. This one, we get 3 into 1 plus 1 by 2 minus x by 3 plus 1 by 2 minus 1 over 2 factorial into x minus 3 whole square. After simplification, we get 3 minus x by 2 minus x square over 24. So this is the solution for the question number 1. As the requirement is expansion of the binomial up to x square. Now, the question number 2 is, part A, by sketching a suitable pair of graphs, show that the equation cot 2x equal to secant x has exactly one root in the interval 0 less than x less than pi by 2. The part B is show that if the sequence of the real values given by iterative formula xn plus 1 equal to 1 by 2 tan inverse cos xn converge, then it converges to the root in part A. The part 3 is, question number 3 is, the square root of 6 minus 8i can be expressed in a Cartesian form x plus iota I, where x and y are real and exact. By first forming quadratic equation in x and y, find the square root of 6 minus 8i in exact Cartesian form. The question number 4 is, solve the equation 5 raised to the power x equal to 5 raised to x plus 2 minus 10. Give your answer in correct to 3 significant figures. The question number 5 is, the complex number u is given by u equal to cos 5 pi by 7 plus iota sin pi by 7 whole raised to the power 4 over cos pi by 7 minus iota sin pi by 7. Find the exact value of the argument u. The part B is, the complex number u and u steric are plotted on an organ diagram. Describe the single geometrical transformation that maps u onto u steric and state the exact value of the argument u steric. The next one is question number 6. The variable x and y satisfy the equation ay equal to b raised to the power x, where a and b are constant. The graph of L and y against x is a straight line passing through the point 0.50 and 2224 and 3.40, 8.27 as shown in the diagram. Find the value of a and b. Give each value correct to the one significant figure. So we shall find out the value of a and b. The next one is question number 7. The question number 7 is, part A, show that the equation tan cube x plus 2 tan 2x minus tan x equal to 0 can be expressed as tan 4x minus 2 tan square x minus 3 equal to 0 for tan not equal to 0. Part B, hence solve the equation tan 3 2 theta plus 2 tan 4 theta minus tan 2 theta equal to 0 for 0 less than theta, theta less than pi. Give your answer in exact form. The question number 8 is, the parametric equation of the curve are x equal to tan square 2t, y equal to cos 2t for 0 less than t less than pi by 4. Part A, show that dy over dx equal to minus 1 by 2 cos cube 2t. And part B is, hence find the equation of the normal to the curve at the point where t equal to pi by 8. Give your answer in the form of y equal to mx plus c. The question number 9 is, with respect to the origin O, the point A, B and C have position vector given by O equal to 2, 1, minus 3, OB equal to 0, 4, 1, and OC equal to minus 3, minus 2, 2. Part A, the point D is such that ABCD is a trapezium with DC equal to 2AB. Find the position vector of D. Part B, the diagonal of the trapezium intersect at point D. Find the position vector of D. Part C, using the scalar product, calculate the angle ABC. The question number 10 is, a balloon in the shape of sphere has volume V and radius R. Air is pumped into the balloon at a constant rate of 40 pi, starting when T equal to 0 and R equal to 0. At the same time, air below begins to flow out of the balloon at a rate of 0.80 pi R. The balloon remains as a sphere at all time. Part A, show that R and T satisfy the differential equation dr over dt equal to 50 minus R or 5R square. The part B is find the quotient and remainder when 5R square is divided by 50 minus R. The part C is solve the differential equation. In part A, obtaining an expression for T in terms of R. The last part is find the value of T when the radius of the balloon is 12. Now, for question number 11 of this session, let f of x equal to 2 e raised by 2x over e raised by 2x minus 3 e raised by plus 2. Part A, find f dash x and hence find the exact coordinates of the stationary point of the curve and with the equation y equal to f. Part B is use the substitution u equal to e raised to the power x and partial fraction to find the exact value of integration ln 3 to ln 5 f of x dx. Give your answer in the form of ln a, where a is a rational number in its simplest form. Now, I shall explain how you can access the solution of all these questions. One question is at the start of this video, but in order to get the solution of all questions, you need to open the URL kingcambridgesolutions.com. After that, you will click on the link, this one, login register link. When you click on the link, you will find the interface as you can see on the screen. After that, you will click on the sign up button. When you click on the sign up button, you will get the interface, this one. You will sign up for the website in order to download all the questions of this session. By providing your username, password, and the email address, you will click on the sign up. On sign up, you will automatically sign in the website. Or you can log in again by clicking on the login register button and by providing your user password as you have during the sign up. After that, by providing the user and the password, click on the login, you will be in the website, this one. After login, you will click on the courses link and click on the courses list. When you click on the courses list, you will find all the different courses on this website. In the category on the right corner, you will, in the category, as I am downloading the paper 1, P1 of the Cambridge. So I shall select this, Mathematics P1 9709 paper 1. So I shall click on the course that I want to download. When I download the course, I shall get the interface, this one, this interface. When you click, first of all, you need to add to the cart. After that, you will get the pop-up that the course is added to your cart. After that, you click on the buy now button. When you click on the buy now button, you will fill the different field of the stripe. When you fill different field of the stripe, after that, you will click on the submit button. When you click on the submit button, after that, you will go to the order history of your count. From the top right corner, you will click the combo box. After that, you will see the link of the order history, your order history, about the courses that you have purchased on the website. When you click the order history, you will see the the order that you have placed. This one. Mathematics P1. When you click this link in your order history, you will find the in the content section of the website, you will see the different icon of the question 1, question 2 up to question number 11. When you click on the file icon, you will download the PDF file, the solution of the question of each question. When you click on the video icon, you will download the video of the question. In this way, you will download all the question of the session October number 2024. Wish you good luck for your exam. See you in the next session of this series. Best of luck.